Hey guys, we will keep, anyways. Hello my students, we keep learning about exponents. So instead of actually learning, we're going to review and do something like more challenging, okay? Because this topic is very long, you will go through it through the entire algebra to prepare you for calculus. Anyways, I'm just giving too much talk, which is irrelevant. Let's keep going. In this example, we have m to the 15th power, n to the 6th power, all to the 3rd power, over m n to the 17th power. What are we going to do? First thing, I'm going to open these parentheses, and then here I'm going to separate m and n. And the rules of exponents tell you if you are multiplying numbers and they have the same power, you can just distribute that power. So m to the 17th and n to the 17th. In the numerator, you're going to have m to the 15th power times n to the 18th power. And in your denominator, you will have m to the 17th and n to the 17th. What is going to happen now? Remember all the rules of exponents? When we divide, we are subtracting the power. So 15 minus 17 and 18 minus 17. 15 minus 17 is going to be -2, and 18 minus 17 is 1. What happens when we have a negative power? We do not leave it in the numerator, or we just do not leave it. If you have negative power, you do not leave it. You're going to move it in the denominator and it becomes a positive power. And n is to the 1st power, so we do not have to indicate the power and leave n by itself. And your final answer is n over m squared. Okay, let's just review what we've done. First, I opened my parentheses and I distributed the power in the denominator. Then I applied the rules of exponents, so I subtracted. Since we're dividing, I subtracted, okay? And I got m to the -2nd power, and since I cannot leave it in the negative power, I put it in the positive power but moved it into the denominator. And since n is to the 1st power, I can just remove the power and leave n by itself. Alright, well, let's keep going. In this example, I have p to the 3rd power all to the 9th power, q to the 24th, over pq to the 23rd power. I'm going to follow the same steps. I am going to open these parentheses, then distribute whatever is here, and then I will subtract. But let's just open parentheses first. And now I'm going to subtract because I am dividing. So 27 minus 23, 24 minus 23. 27 minus 23 is going to be 4, so p to the 4th power, and 24 minus 23 is 1st, so q. Your final answer is p to the 4th power, q. And let's do the final example like this. X to the 14th power, y to the 3rd to the 5th, all over xy to the 13th power. I'm going to open parentheses. That is always my step. I either put everything in the parentheses or open my parentheses. Here, since I see them, I'm going to open them. When I don't see them, I put everything into parentheses. Anyways, y to the 3rd power to the 5th, we're going to multiply, and here we're just going to distribute, right? X to the 13th, y to the 13th. What are we going to do now? We're just going to subtract, right? Because we are dividing. So 14 minus 13, 15 minus 13. And your final answer is xy squared. Yeah, this is just an extra step. We're combining everything that we've learned about exponents and doing more challenging problems. Now let's do something else. We're also going to deal with exponents, but now we're going to have actual numbers. I have a cubed divided by 4 to the 5th power. That is easy to do with a calculator, but we're learning how to deal with everything without a calculator. This may seem just a little bit challenging. Sure, you can first multiply 8 times 8 times 8, so like 64 times 8, divided by 4 times 4 times 4 times 4 times 4, That will be a large number, but I'll show you a shortcut. Okay, you need to learn to recognize what kind of numbers these are. 8 is a cubed number, so it is 2 to the third power. You will learn to recognize it the more you do it. The more often you see it, the easier it will be to recognize it. Like 4. 4 is 2 squared, right? It's a squared number. 8 is a cubed number, and 4 is a square number. I'm going to rewrite 8 as 2 to the third power to the third power. And now I'm going to rewrite 4 as 2 to the second power and leave my fifth power outside of the parentheses. Okay, now let's get rid of the parentheses. When we see powers like this, power to power is multiplication. You will have 2 to the 9th power over 2 to the 10th power. What is going to happen with powers? You're going to subtract them. So 9 minus 10. And what will be 2 to the negative first power? We're just going to move this 2 in the denominator and we will be left with 1/2. You see, this is a lot easier to do when you, I guess, factor it, or like how you say it properly. When you turn 8 into 2, when you bring numerator and denominator into the same base, because when you have the same base, then you can work with your powers. Let's do another example that is similar to this one. I have 16 to the 4th power over 8 to the 6th power. I recognize that 16 and 8 are powers of 2. Is that how we call it? Like 2 times 2 times 2 will give you 8, and times 2 will give you 16. So 16 is 2 to the 4th power, and 8 is 2 to the 3rd power. Again, what did I do? Because I have exponents and I have nothing else to do, and I don't have a calculator, I am going to simplify it by bringing these numbers, these exponents, to the same base. And the same base that they have is 2. And then I'm going to deal with my powers. Now, to open parentheses, I'm just going to multiply it. 4 times 4 is 16, 3 times 6 is 18. And now I'm going to subtract my powers. So 16 minus 18 is negative 2. And 2 to the negative 2 is going to be 1/4. And that is your answer. Again, I do not want you to get intimidated because it is pretty scary. But once you start to recognize it, I know that these are the powers of 2 because they can be divided by 2 easily. And then I just keep like factoring things out and see if I have the same base. Let's do our final example. Here I have 81 to the 5th power divided by 27 to the 6th power. What am I going to do? I see that 81 and 27 have something in common. That number is 9 because 81 is 9 times 9 and 27 is 3 times 9. Okay, let's just write it. But look, I can keep factoring my 9s and factor them into 3 times 3. So 81 is 3 to what power? How many 3's do I have? I have 1, 2, 3, 4. So 81 is 3 to the 4th power. And raise all of that to the 5th power. And 27 is 3 to what power? We have 3 3's multiplied by itself, so it's 3 cubed. Okay, now they have the same base, and because they have the same base, we can distribute and then subtract. We have 3 to the 20th power over 3 to the 18th power. We're going to subtract the powers, so 20 minus 18 is 2. So 3 to the 2nd power, or 3 squared. And when you square 3, you will be left with 9. All right, let's go over again. What did I do in the beginning? In my first 3 examples, I opened parentheses first and I distributed the multiples with the same power. And then I was able to subtract it and find my final answer. In the last 3 examples, I had to recognize what will be the common basis for these numbers. The common basis for the first and second was 2, and common base for the last one was 3. You will learn how to recognize it the more you do it. But this is what you're going to do once you recognize it, okay? you can just keep factoring it if you do not recognize it right away. And when you factor it, then you can combine it and write it as a power of something. This is actually number theory. You can take that class in college. It's very interesting, but you have to like write proofs. It's a little bit annoying. But anyways, this is it for this class. Like, subscribe, comment, let me know what videos you want to see, and I will see you in the next lecture. Bye bye.